All right. Yeah. Well, that's a bit too loud and a bit crackly. Yeah. How does that sound for everybody else? Good. Adequate. Okay. Could I get some water, please? Thank you. Are we ready to get going? Doesn't sound great, does it? If I put it there, it's meant to be for the recording. Yeah, I think it's a little bit of an annoying. Yeah, it's not good, is it? Yes, maybe. I don't know. Yeah, he's giving me water. It's picking up my breathing if I. That's okay. I was thinking if. Yeah, it was a very long time ago, and let's see if I can find it. Wonderful, thank you. So yeah, the microphone isn't working well. That's okay. No? That seems okay. I don't know what you did, but
me neither.
No, but it seems okay.
How long is the talk?
It'll be an hour, I think. But if we keep getting questions, then I'll keep answering them until people kick me out. But I'll probably try to aim for about an hour. Yeah, I was looking for that email where I said I would promise to come, but I think it was about 2015 or maybe even earlier. When did you start ABLA?
2015, 3 years ago.
Maybe. Yeah.
Lambda World.
Was it Lambda? Okay. Right. Yeah, it was quite a while ago.
Okay. Welcome everybody. John Petty is a man of his word. Because 3 years ago we were talking about him doing a meetup here and giving a talk in the Scala group, and yes, now.
Well, I'm.
Thank you very much.
Thank you. I'm really glad to finally be here after what was 3 years. I didn't forget, and I remember saying to Juan Manuel back in 2015 that if I'm ever in Madrid, or if I'm ever passing through Madrid, and you know I do travel around a lot, so it's not unlikely I would pass through at some point. I would definitely stop by and give a talk. So yes, here I am. It's not the talk I planned to give back in 2015. Because Fury didn't exist then as an idea, but I'm going to talk about Fury. Now I don't know how many people here know anything at all about Fury. Who knows nothing at all? Okay, so a few people. So do the other half of you know something about Fury? Yeah. Okay, so probably about half and half. So that'll be interesting. So I will try and explain some of the motivation behind building this new build tool and dependency manager. And I would also guess that most people here use SBT. Does anybody not use SBT for building Scala? No, we had when I went to Barcelona a couple of days ago. There was one person using Maven. People still use Gradle and Pants and other things, but I think the vast majority of Scala users are settled on SBT. So I'm looking to provide something which is an alternative to SBT, not necessarily a replacement, but something that can coexist with SBT. Certainly won't be replacing it at any time yet. But it uses a very very different philosophy from SBT, which for me, the ideas that I put into Fury over the last 6 months or so evolved probably over the course of about 5 years. I think about 5 years ago I was people were still using SBT 5 years ago, but I was dissatisfied with it then as I am today. And I had these other ideas as to how an alternative universe could work. Now, there are two main problems I want to solve, and they're somewhat independent. One of them is the complexity of builds, and anyone who encounters SBT for the first time will probably copy and paste a template and modify a few things to make it have the right dependencies, and it'll be an okay experience. I think when you come to maintain more complicated SBT builds, you start fighting against it more than appreciating it. And does that sound familiar to anyone, or am I? Yeah. It's worth me asking as well. Is there anyone here who does really like SBT and they think that they're happy with the way it works? Don't be embarrassed, because I know a lot of people do. The people who tend to like SBT are the people who are experts with it. Now, I, for whatever reason, was never really motivated to learn all of the details of SBT. It always seems like not so much inherent complexity, but incidental complexity. My personal motivation for giving time to incidental complexity is very limited. So instead, I decided to write Fury. I don't know if that's a good idea or not. You see, it's taken me 6 months so far, and the release is probably still a couple of weeks or more away. Now, there's a few things I do differently. What I could do is start listing the differences, but I think what I might do instead is just jump straight into a demo of how Fury works, so you can see it from a sort of normal, what I think might become everyday usage. So this is just a normal console. I'm running ZSH, but it's just a shell. And what I'm going to do is start a project. Now, at any time, if anyone has any questions, just shout out. There's only 10 or 12 of us, so you're not interrupting anybody if you want to ask a question. And questions probably will come up, and I'm more than happy to answer them as we go. So I'm going to start a new project. I'm going to start actually a workspace rather than a project. A workspace is a collection of projects. So let's just make a new directory for that, and I'll call it ScalaMad. We are ScalaMad and not Mad Scala, aren't we? ScalaMad. Okay, yeah. So I've got an empty directory, and I'm going to initialize it. I'm going to run Fury. Oh, is Fury running? Let's just start. Check it's running, and initialize it. And you can't see quite, but it's given us some messages here. It's initializing a new directory, the new Git repository, and added some files, and it wants my Git password, my GPG password, so it can sign that commit. I got the password wrong. Okay, so that's been done now. There is a bug here, which if anyone knows how to fix that, how to stop that message appearing, let me know at some point. That one is in the Fury issue tracker if you want to comment. But essentially, we've got a new directory. We've got a new file here, which is called workspace.fury. Now, this workspace.fury file is basically going to be the definition of our build. But we're not going to look at that file. It's just going to remain there. What we're going to do is run some commands which modify that file and allow us to specify the build. This is probably more similar to using something like Git than using something like SBT. We run commands. The commands make some change to the workspace state, and we don't edit any files directly. Okay. So the first thing I want to do in my workspace is create a project. Now the hierarchy of entities is we have a workspace which corresponds to a directory on our hard disk. That directory may contain one or many projects. Probably in most cases it'll be one, but it could contain more. And a project is probably very similar to your existing concept of a project. It's a project like Shapeless or Monix, the sort of thing that would have a single repository on GitHub and be managed with a single version number. In a project there are modules, and these correspond to submodules in SBT. And a module is basically one invocation of the compiler. So one way of looking at Fury is that it's just a way of managing a graph of compiler invocations. Each module, each run of the compiler will take some source files, it'll take a class path, some parameters, and it will return, it'll output some class files. And those class files sort of feed into the next node in the graph. Are you all okay with that sort of model of a build? Yeah? I just think of it as simplifying it down to its fundamentals. It is just a series of compilations that we chain together in a graph, and at the end of it all, we get hopefully a jar file. So that's what we're going to do, and I'm going to start by creating a new project. Now you'll see that I'm pressing tab, and I'm getting tab completion on these commands, which is one of the most important things I wanted to do, and to make the user interface really simple and easy to use. And in our ScalaMad workspace, we're going to create a project called website. So that command ran instantaneously, more or less. We got feedback straight away, and we get a message saying that the current project is set to website. So maybe nothing too surprising there. And we're going to do the same thing with module, and I'm going to call the module Backend. So we've got a Backend module here now. Now nothing's visibly changed in the directory, but if we run Fury project list, we get a list of projects, and there is only one. And if we run Fury module list, we get a list of modules, and there's just that backend one. So there's a few things to note here. There are some empty columns here. We don't have any dependencies, sources, binaries. We haven't chosen a compiler, and there are no parameters. And our website, it has a module, so there's one block for each module displayed there. We didn't give it a description, and we didn't specify the license. But essentially, the commands we've run are managing these lists for now, at least. And I can update the project to set the description to something like a website for Scala Madrid. And if I list the projects, that description's been updated. So now I just ran two subcommands there, project and module. If I press tab again, we get a list of all of the things that you can possibly do. So you can just glance through that list and have some ideas of the kind of things, the sort of entities we might be looking at later. This is just a teaser as much as anything for what Fury can do. And what I'm going to do is get on with building or writing some source and then trying to build it. So I'll keep the source very simple. So it'll just be to demonstrate that we can actually compile something, and we can have several phases to our compilation. So I'm going to create a directory for the backend, and I'm also going to create a front-end directory. So I'm going to have two modules. So we're going to compile one, and then we'll compile the next one. Any questions so far? All making sense. So, sorry? No. Don't be shy. So in our website project, let's just do something really basic, just a single object, just so it's got something to compile. And in the front end, I'm going to do something a little bit more interesting. Keep it in the same package, but let's have a seal trait, which I will call door. And my door is either open, closed, or it's ajar. Okay, I've got a tri-state door. That should all be okay. So I've got the sources, but Fury doesn't really know where they are. It doesn't know that it has to compile them. So what I'm going to do next is just add the source to the backend. Now, when I created that backend module, it said current module is backend. So any operations we do now will apply to that module unless we specify a different module. So there's a concept of a current module, current project. Now, if I run the command fury source add, and then I press tab after that -s, it's offered me local source backend and local source frontend. Local means within the current repository. And when we initialized, we created a repository. So within the current repository. We might later want to include some sources from a remote repository, but for now we're going to deal entirely with the local one. And I can specify those two directories. Now the reason it's listed these directories for me is because it's gone and searched through the directory structure, and it's found all of the directories that contain files called star.scala, something.scala. So these two are candidates, and I'm just going to specify this one. So that will add all of the sources that are in that are within this directory to that module. And if I list the modules again, we can see that the backend sources are in there. Let's add the front-end module. So I will add that like that, and in the same way we can add the sources like that. And what I want to do is I want my front end to depend on my back end. So what that means is I'm adding the edge to the graph. I'm adding the arrow that says we must build the front end after we've built the back end. And we do that with a dependency. And remember, my current project is front end, so I'm adding dependency on back end. And we can either specify it as a module in the same project or as an absolute project/module link. Alright. List the modules again. So there they are. That arrow points to the current one. Now everywhere here you can see several different colours. The purpose of this is to give you every indication that I can, every hint as to what different sorts of entities we're dealing with. So everywhere you see something blue, that is a module, and that's something you'll become familiar with if you use it. Everywhere you see something green, that's a project. Yellow is for schemas, and I'll talk about them later. This sort of salmon colour is for the workspace, and repositories are this red-orange colour. So the user experience, I've put a lot of thought into how to make it as intuitive as possible, how to make it easy for you to, without being explicitly told, to get an idea for what is going on. This line here is maybe interesting. This tells you the current context for the information beneath it. So what that's saying is we're in this workspace. We're in the default schema. Remember, schemas will come later, and this is for the website project. Now, if I list the projects, obviously there's no, we're not listing the projects for a particular project. We're listing the projects for the workspace and the schema. So this will give you a hint as to what you're looking at, what all the information is about. Okay. So on just off the screen, I've got a script that is hopefully reminding me of the steps I need to do. Yes. There are two, but yes. So that's the back end and the front end. So I did used to write a number there. That previously it would say 1, 2, 3, but I found that if I used these little blocks, it gave me a much clearer indication as to where most of the modules were defined. What I might have to do is if we have projects that go into hundreds of modules, then maybe I will put a ... in the middle or something. But yeah, again, it's a sort of visual hint, so that you can just glance at it and hopefully get a good idea straight away as to what's happening. So this is our list of modules. Now, maybe you've noticed there's something obviously missing. No compiler. So I haven't specified the compiler. Now, when you install Fury, it doesn't need a compiler. It doesn't come bundled with an assumption that you will use a particular version of the compiler. You do have to specify what the compiler is. And a compiler is actually a module. It's a dependency on a module, almost like any other module. It just happens to be that module is marked as being a compiler that we know we can compile with. So what I could do is I could define my own compiler module. But I don't really want to do that because it's probably a bit too much work. So what I want to do is use someone else's definition of a compiler. And the way I'm going to do that is I'm going to add a repository which contains definitions for some compilers. And the repository is just a Git repository, and it's in fact just another workspace. So whilst I'm defining my workspace with my project in, I'm going to import another workspace. And the process of importing that workspace gives me access to all of the projects and all of the modules in those projects in my own workspace. So I'm going to do that with adding a repo, and I'm going to specify that I'm going to use shorthand. GH is for GitHub, and the repository is at /base. Now I'm going to add a little flag here, which for the time being you can just think of as specifying the particular variant of the workspace, and that variant is going to be the version number of the compiler that I want to include. So if I do that, now this is the step where I was going through this script and it broke in Barcelona. Maybe it's Barcelona's fault, who knows. But I will now test to see whether that has worked. If I list the repositories, we now have, in addition to the local one, which is, you see it's got a Git hash. We've now got the base as well, and the base is specified to that remote address that we added. We are tracking the master branch by default. I didn't specify another branch, but I could have done, which happens to have this commit hash. The fact I've got the commit hash there means that the repository has successfully cloned in the background. It's only a tiny repository, it's only just a definition. And don't worry about local for now. Now what that means is, because I've imported that repository, if I run Fury Workspace projects, not only do I have website, but I have Scala and even Dotty there as well. Which means that I can now update the module to specify the compiler, Now you see at every stage I get tab completion. I can specify the compiler to be Scala/compiler. And if I list the modules again, we've now got Scala/compiler. Remember, project in green, modules in blue. And I want to do the same thing, but I'm going to specify explicitly to do this to the backend module. So, those are two modules. I've specified the compiler, specified some sources, a dependency between them. They're both libraries. I think I could try building those now. Does that seem okay? So I'm just going to run Fury, and what that will do is initialize Bloop, which runs in the background, fire up a new compiler, and it will compile those two. It's a bit slow that time, because everything is being done for the very first time. If I were to run it again, then it's actually very, very fast. Does anyone know anything about Bloop? You've heard of Bloop? Does anyone not know anything about Bloop? Okay, so Bloop is something developed, it's a tool developed at the Scala Center in Switzerland, which provides a very lightweight wrapper around the compiler that keeps the JVM the compiler's running in hot. So if you use SVT, maybe you'll notice that when you compile something the first time, it's very slow, like we saw here, but every subsequent compile gets faster and faster, and it's basically because Hotspot is doing the various things it does to improve compiler performance. All of the class files will be loaded and cached, and everything will be optimized. So Bloop gives you basically the means to invoke the compiler, but have it resident in memory, so that every subsequent compilation is faster. So that was running Fury for the first time on a very simple graph. Now the graph only has two nodes, there's one edge between them, so it's not very exciting there. What I might like to do is add some dependencies from elsewhere. So I'm going to add, I'm going to import a workspace that contains some of my own projects. So I will do that with adding a new repository. Again, it's on GitHub, and it's called Overlay. I'm just going to give it the name propensive. And if I list the repositories there, we can now see that prop is listed as well. What I didn't do is I didn't actually import it as a workspace yet. I can do that in a separate step. The first time I imported the workspace, specifying the -i that's specified to import 2.12.6. Here I'm going to add an import, and if I press tab, we can see that the options for the options that we could import include the base. We can import the 2.11.11 branch, the 2.12.6 branch, or the 2.13.0 milestone 6 branch, or we can import the workspace from the prop the prop repository that we've just cloned. So if I do that, and I check the list of projects we now have available, we've got many more. These are all available for us to depend upon. So what should we do? How about I'll add a dependency on Guillotine. Guillotine is a library I wrote for executing stuff. Basically running shell commands. So I'll add a dependency on that to the module Backend. I think that should work. And let's add a dependency to the front end on, what have we got? How about Magnolia? Has anyone used Magnolia, by the way? No? Okay. Not yet, okay. So, I've added those dependencies. Now, if I run Fury again, our graph is now suddenly more complicated, and it's going to build all of these things, including some other things we didn't ask for: totalitarian, contextual, Mercator, because, for example, guillotine depends on mitigation, mitigation depends on totalitarian, Magnolia depends on Mercator, guillotine depends on contextual. So it's formulated this graph for us, and it just went and built everything. It took 10 seconds to build all of those projects in this graph. You will also notice that it was doing several things in parallel. Did you spot that? I can if I do it again. Well, let me just clean, and if I do it again, you should see several of those are lit up at any single time. So we've got 3 running in parallel now. The later ones, as you can see from the graph there, each one depends on the previous one, so we can't parallelize those. But it will do as much as it can to run things in parallel. So that's actually, even though I deleted all of the files, the build time is getting faster and faster. So let's do another clean and then try that again. This is how long it takes from clean after a few runs. So it's 3.5 seconds. It's building 9 or 10 projects there, which is pretty good. So that's an example of quite a simple building quite a simple project. And of course we can just edit the sources and do whatever we want to make it actually a project that's useful in some way. Any questions? Okay, let's just make an error. I'll just delete the C there, so there's now a failure. If I run that again, we get a notification that there is an error, as indicated by that red mark there, and the error gets printed out at the bottom. So it might be the case that we have errors in several modules which are running in parallel, in which case you'll get all of those listed independently, one after the other, but they've got to be fixed somehow. Is that okay? So let's just change that. Okay. So what I've been showing you so far has been almost entirely related to the ergonomics of defining the build. From my point of view, I think this is a nicer way of making changes to the build. We get tab completion. We get an interactive experience. We don't have to compile and then run our build in order just to know what it's going to do. We get this nice graph, and I hope it's informative. I hope it's clear what it's doing at each stage. I haven't shown you two other things I haven't shown you. One is testing. A lot of people like to do testing. So I'll try and do a quick demonstration of that. I was just playing around with that on the Metro as I came up here, so it might not work, but we'll give it a go. And the other thing I want to talk about, which, remember at the beginning I mentioned the 2 main motivations. The other one is relating to the ecosystem, the entire Scala ecosystem that we're using. And I've got quite a lot to say about how Fury can help fix some of the problems I see with the Scala ecosystem. But let me just show you the testing. So just check that builds again. Good. Now I might like to add another module called tests. And what I think I might do is I might specify it not to be a library. Library is the default, but I will make it an application. And I might as well specify the compiler while I'm here. And I think that's all I need to do. what I need to do for now. And what I'm going to do, so we've now got 3 modules. Our tests will depend on the front end, and I would also like the tests to use a test library I've written, which is called Probation. So let me just check this is all looking okay. Our tests depend on the front end. That's one thing we're going to test. They also depend on the test library. It's not a framework. It's a library. It's another deliberate decision I made. But you could depend on whichever test library or framework you wanted to. Now you notice there's nothing particularly unique to testing here so far. I gave it the name tests, but apart from that, I've just called it an application. Let me add some sources to that. And there's no source files in there, so I'll have to specify it manually. We don't get tab completion if it doesn't know that there are sources there. And in the sources, I'm going to just define website tests. I'm going to define an object. And I'm going to import probation. Now probation is very, very simple. What it allows you to do is to define some code that will run some tests. And the tests are things like check something, and I'm going to check that if I make the test fail, then you get to see some output. So this is very, very, very simple. The syntax, I'm not really here to show you the testing library, but hopefully you can read this and understand immediately what it's going to do. It's going to check that 2 + 2 = 5 and hopefully fail. So I define that. Now what I need to do, so that was called, the object is called tests, and it's in website.tests. I'm going to update the module to specify a main method, which will be website.test.tests. Now, I think if I run Fury again, it will build all of that, and oh, this is interesting. There's actually a bug. There's a bug in my build definition, I think. So let me go through the process of trying to debug what's happened here. So it failed to build probation macros because, well, close your eyes for a moment, and I will hack this into working. Oh, I know exactly why this has happened. I told you it wouldn't work, didn't I? Let me just try and do that. It's remarkably easy. And I forgot to specify the compiler. I thought I did specify the compiler. Scala compiler. Okay. Right. So you can open your eyes again, and now if we run this build, not only did it do all of the compilation, but we got to the tests and it ran the tests and they failed, so we get a red mark there, and we get the output here saying that check something failed, and it failed very quickly. So that's running the test library. Now your tests could be running some unit tests, but equally you can imagine if you had some integration tests, or if you had any sort of application you wanted to run as part of a build, you could just invoke that in the same way. You define an application, you define an object with a main method, and you just run it. So this is very useful, not just for things that happen at the end of the build, like tests, but also for things that might happen in the middle. You could use this for code generation. So if you wanted to generate some code, you could create an application module, and Fury would build it, would compile it, and then it would run it. And running that module could then generate some source files which get put into a directory. And it's just an application, it can do anything, so it can output source files into a particular directory, which could then be used as a Fury source directory further downstream. So although my build is defined in quite simple terms, remember it's just a graph. It's just a graph of modules which have inputs defined as class path sources and parameters, and outputs defined as class files. By having the ability to actually run things in the process of running of building the graph, we can actually do arbitrary things. So we do get more or less the full power that we have with SBT in what I think is an easier to understand model. It's very easy to look at this graph here and have a good idea as to what will be running when, why it's running, what is depending on it that requires it to run. So that's all well and good, but what I'd like to do is run Fury test, but test is not a command. But I can make it a command. I can add an alias. I can add an alias which I call test, and I'm just going to call this test the ScalaMad website, and that will specify the tests module. Now I think if I do that and I press tab there, you'll now see that there's an additional option called test that would allow me to run test, and that will do what we need to do with a simple subcommand. So Fury is also extensible. You can add. They're pretty simple aliases. I might need to add more features to this in the future, but essentially what it's doing is running one particular or compiling or running one particular module from those that are available in your workspace. Sorry? What sort of scripting are you imagining? Well, the thing is that running a series of Fury commands is something you do once. It's not something you repeat. So that script is maybe useful for me when I'm testing Fury, but it's probably less useful as part of the definition of any build. But the question about scripting does sort of bring up other questions about how you do other things. So people use SBT builds to do all sorts of weird and wonderful things. People will include connecting to databases as part of their projects, or building Docker instances, and there are plugins for doing that in SBT, but that's not something I really want to add all of the functionality for with Fury. It makes them less repeatable for a start. But because with Fury you're typically invoking a command to run the build, and most of what, well, all of what Fury is doing is sort of within the JVM world. It doesn't deal with Docker. It doesn't deal with, doesn't really even deal with formatting your source code. So things like those, things like source code formatting, can be done as a separate step prior to running Fury. Now maybe that's in a make file. Now people laugh at make, but it's been around for 40 years. And there's a reason it's been around that long, which is that as simplistic as it might be, it does work for many things. It is reasonably straightforward to understand, and given it's existed for 40 years, it's not going to go away tomorrow. So I would recommend make as a means of sequencing, for example, source code formatting prior to building. And then building the Docker instance, if that is what you're doing, or some sort of assembly, that could be done after Fury runs, on the basis of the output of Fury. So I would, one thing I do want to do is sort of redefine the idea of what is a plugin. Because in SBT, any sort of functionality is a plugin. Whereas if I look at each plugin that's been defined for SBT and I try to think how the same functionality would be applied to Fury, it's often a different answer in each case. So some things run after Fury, some things run before Fury. Some things will be absolutely fundamental to building. So one example might be running the scoverage plugin, or scoverage, depending on how you say it, which gives you details about code coverage. Now that is sort of fundamental to how Scala, or how you do coverage testing in Scala. And that's something which I think I would want to integrate natively with Fury, add native support for it. And in the same way that maybe I don't know if you're familiar with like the Linux kernel versus the Windows NT microkernel. Linux compiles everything. It compiles all the drivers in the same compile run. It's a huge thing. That fits more closely with the Fury model. Whereas the Windows NT model says, well, I'm going to define interfaces for drivers, and then all of these drivers have to build separately and interact with the kernel via these interfaces. That's sort of more the SBT model. And I don't have any strong opinions on which was the correct model in terms of the operating systems, but I'm very, very nervous about implementing any sort of plugin architecture when they've been demonstrated many, many times to be fragile and brittle and very difficult to upgrade. So if anyone remembers the upgrade from Scala 0.13 to 0.1, there was a lot of work, particularly with getting plugins converted. And I think what happened, more or less, was that the SBT team in Lightbend did a lot of the work in migrating the plugins for those authors and created pull requests. That's not something I want to do. I would rather decide that if I want to provide some additional functionality, like code coverage support, then I'll go all in and I will implement that natively in Fury. Or I will use scoverage, but I will provide the support for that natively. So not only that, but you get a richer user experience when working with that. I've answered more than the question you asked, actually. Does that cover that question and related questions? Yeah. Does it invite any more questions from anyone? No. Okay. So the other thing I wanted to talk about is what I intend to happen with respect to the Scala ecosystem. And I can tell you a little bit about what happens at the moment. Now, in a few months, I'm told February, Scala 2.13 will be released. That the final version will be released. And first of all, how many people work on projects with more than 5 dependencies? more than 10 dependencies, more than 10 transitive dependencies, more than 50 transitive dependencies. So there's a lot of projects that you probably depend on, if not directly, then indirectly. And all of those have to be converted to work with Scala 2.13 if you're going to use Scala 2.13. Apart from the Java ones, but all of the Scala ones need to be converted, upgraded. And the upgrade might not be too difficult. It might just be a matter of publishing them to Sonatype. It's probably not a huge amount of work, but as the ecosystem is changing, as new releases come out, as soon as any project makes a release, everything downstream of that is able to depend on that new release. You can't depend on a new release before the release is made. So what has happened as a result of this is that when, for example, Scala 2.13 comes out, within a couple of hours of that, Sebastian Duren, who was a PhD student until earlier this year, he will publish a new version of Scala.js that works with Scala 2.13. And he'll be waiting for this moment. It will be in his diary, and he will know that he's not taking vacation at that time. I'm not joking, he does this. He knows that he has to be around to press the button to publish. And the reason is that he knows that anyone who publishes anything in Scala probably depends either directly or indirectly on Scala.js. If he doesn't do that, then he is holding up the entire ecosystem. And it seems very mad to me that a PhD student, like we have this industry of tens of thousands of Scala developers, I think it's probably tens of thousands now, around the world, are waiting for one PhD student to publish, or to press a button to publish a binary, so that they can start using the latest version of Scala. But it's not just him, it's everything downstream of him. So after Sebastian does that, Bill Venners will publish Scala Test, because everything depends on Scala Test, more or less. And then other people like Miles Sabin will publish Shapeless within a few days of Scala 2.13. Cats will get a release. And all of these people are trying to schedule their time to get these releases out the door. Now, the people at the top of the chain, whose names I've mentioned, they put the time and care and attention into being there and doing this. People further down the chain, myself included, generally don't put as much, or aren't generally so aware of release schedules, and so tend to be a little bit more lax in when we publish. So there's a compounding effect in that if your project depends on several others, you have to wait for all of those and all of their dependencies and all of their dependencies to be published before you can publish. And what this means is that a lot of projects are just very slow to be released. They're all waiting for maybe just one thing, but all waiting for something before they can get out of the door. And it means the whole ecosystem is very, very slow to respond. It means that we can't react quickly to changes. It means we have single points, not just one single point of failure. We have several independent points of failure, any one of which could cause problems for the entire ecosystem. Now, what would probably happen is if someone doesn't publish, say Bill. Well, what Bill does is Bill pays somebody to publish for him. But if he didn't do that, if Scala Test didn't get published, then probably someone would fork Scala Test. They would create a new account called forked Scala Test, and tell everybody, now we're going to depend on this version because we don't know where Bill is. And people would find a way to work around it, but it wouldn't be an ideal situation. So this is what I want to fix. I want the whole process of publishing to take minutes rather than months. I want it to be possible for not just somebody, but anybody to publish a project. So if you imagine an alternative universe where people don't have SBT builds, they have Fury builds, and those Fury builds are repositories, and anyone can clone that repository and write their own build, or change the build, update the build, and anyone can pull in dependencies from other places, including source dependencies. So if I wanted to write a build for Shapeless, I can do that. I can say, I'll just do it here. I can say Fury repo add GitHub /miles sabin /shapeless, and if I do that, if I list the repositories, that one's going to take a little while to clone. We've got a fast connection, so we've got. Is there any reason why that commit hash has an extra digit? I've never seen that before, but I mean, obviously it's part of a much longer commit hash, but so it's cloned. It's cloned Shapeless, and I could. There's nothing to stop me adding a project called Shapeless, adding a module called core, and adding a source to that, which is somewhere in Shapeless, core, source, main, Scala. That looks like a reasonable path to some Scala sources. And this is never going to work, but specify the compiler, and if I try and build that, it will try and build Shapeless core. It fails because it needs some more dependencies, but that was really easy for me to do. I just did it on a whim, and many projects you can just quickly write that build, and you can then publish that. You've published a build for any project, and anybody else can then depend on that. I haven't shown you yet the process of publishing, which is yeah. So when you publish, so if I decide to publish this build repository, this workspace, so other people can pull it in. What I will do is if I list the repositories, you see I have both a commit and a branch or a tag which I'm tracking, and obviously branches change. They point to a different commit on different days of the week. When you publish against an exact commit. Now, there's always the risk that someone could remove a commit from the repository completely. Now, in that case, it's sort of you indicate you indicate an exact commit. You don't indicate you indicate the hash, so we can rely on that hash being the same. We can't rely on the hash existing for all time, because you can delete data from Git if you try hard enough. But we won't ever have a dependency on a tag, which can change a little bit more easily, or on a branch, which can change very easily. So we do at least have that sort of stability. But yes, there is always the risk that a build breaks in the future because someone deletes a commit hash. I should show you the publishing process, because How many people here, if anyone, has published to Sonatype ever? 2, 3, maybe? How many people found it really easy? It is very hard. Now with Fury, you would probably expect it to be easy because it is just a repository. So we can actually do a workspace publish, and in order to publish, I need to specify a couple of things. A tag. I'm going to call this v. Actually, before I do this, I want to publish it somewhere. So I'm just going to create a new repository on my GitHub account. Has anyone used the hub command? The hub command is basically a command line interface to Git. It's nothing to do with me, but it's created propensive/ScalaMad. It's easier than going to the GitHub website. So if I publish with a tag v1.0, and I'm going to specify a key. Now this will use my Git my GPG settings to see which keys are here. You still have to set up GPG, but if you've done that, then it's a matter of specifying the right key, and it's going to ask for my password, and that's running some Git commands in the background. It's pushing to the Git repository remotely. That's published. You can tell someone that in propensive/ScalaMad there is a workspace which you can import into your own workspace, and you get all of those projects which I've defined today. It's as easy as that. Yeah, so it doesn't publish binaries. It publishes the specification of the build, which is specified, which consists of the sort of details you see here, and that is all the information that somebody else needs, in theory, to rebuild all of the things that we were building. And it's been signed by my key here. So I haven't added the features yet, but you'll be able to verify that when you import a workspace, you can see who signed that, and you can see you can then verify that. It is just yeah it is yeah. So Fury gives you a command that goes through 2 or 3 of those steps. There's only 2 or 3 steps. I think it's tag the repository. Oh, sorry. Sign the workspace file. So create a signature. Tag commit it. Tag the repository, and push to the remote. That's basically all that's required. And you could do that yourself. Yeah. I would say maybe it doesn't even need a built-in Fury command, but it exists. It's a single command. Yeah, I'll show you, and I will explain it a little bit first. So what you can see here is a lot of white space. There are some things with names. You see reference to things like guillotine. You can see, for example, other references here. This file is not designed to be human writable. It's only partially designed to be human readable, but the most important thing about it is that it's designed to be human diffable. So the diffs, when you create a pull request from one project, one build specification to another, you will see a diff, and it will say things like the dependency on guillotine changed to something else. I'm nervous you're taking a photo of this. No, it's fine because it's all published. It's published on my GitHub repository, so you can look at. Oh no, it is. It's got shapeless. It's defined. You can see there's the website project, and there is the shapeless project as well. The file format is actually very simple. It's the format is called OGDL, OGDL, which is something like Object Graph Definition Language. But the markup consists only of new lines and tabs. And seeing as I don't use new lines and tabs in any of my data, it means I can put data in here without escaping it, without that complexity. But the biggest benefit is for diffs, and because the file format is quite concise. So that's what gets published. That's what gets read in. If there's a .fury directory, which is a hidden folder that contains a lot of the details. If I look in here, you can see the repositories that got cloned. If I go to the base repository, you can see that has its own workspace file. And if I look at that, this is the definition of the base repository, which contains those definitions of the compiler. So my hope is that people will publish builds for lots of projects. It's very difficult for a new build tool to come onto the scene, especially one that requires all its dependencies to use the same build tool. You maybe think it's going to be very, very hard to bootstrap an ecosystem that's built around Fury, when SBT is very much dominant in the marketplace. But I don't actually have to persuade all of those project owners to migrate to Fury. I just have to persuade a few dedicated people to help me convert builds to use Fury and publish them. Now, whether as time goes on I continue maintaining those builds, or whether they get at some point passed to the project maintainer themselves, that's a question. But we could have just a few people working to publish builds for all of the key projects in the Scala ecosystem, and once they're done, we're almost bootstrapped. Remember, I explained that we're importing workspaces, so I can import a workspace that contains definitions of the compiler. I can import another workspace that contains definitions of my own projects. Now, each of these workspaces we're importing works in isolation and as an import, and the importing is recursive. So the workspace containing all of my projects imported a workspace specifying the compiler. So they actually form a tree of dependencies. The workspaces form a tree of dependencies, which gets composed into a collection of projects. Now, the composition that happens when we're sort of recursively bringing these workspaces in, and hopefully in our workspace everything is somehow coherent. The way this happens is via care and attention to conflicts. So, has anyone here experienced diamond dependency? If you've all had some experience of where you're building a project and you depend on two other projects, and those dependencies both depend on another project, the same project, but different versions of it. Now, if those are just minor versions that are different, they're probably compatible if the author's taken care. And what Ivy and Maven will do, and consequently SBT, is it will quietly it'll log that it's happened, but it will evict the earlier version and just use the newer one. And it will hope, and it is very much hope because these are binaries, it will hope that everything continues to link. Now, one advantage of the Sonatype Maven Central model is that things do link because you have to wait for the dependencies to propagate through the system before you can depend on them. That's why you don't generally get linking errors. But you still get evictions, and the evictions may break things. And if you have two different versions of the same project, which are API incompatible, and one of them gets evicted, suddenly you start getting errors, not at compile time but at runtime, when you get a no such method error, or you get a no or class not found exception. And this is terrible. We don't have a good means of avoiding this. So what Fury will do is it requires, as a necessity or as a prerequisite for you to run a build, it requires that every project that you depend on must resolve uniquely to a single definition, a single identical definition. So if you have one set of projects that depends on Scala 2.12.6 and another depends on Scala 2.12.5, that's a conflict. It's a conflict you can easily resolve, but it's an explicit resolution. So you have to make the decision: am I going to choose Scala 2.12.6 rather than Scala 2.12.5, or am I going to use Shapeless 2.4 instead of Shapeless 2.3? That's a command you run. It's not implemented yet, so I'm talking hypothetically, but the design is there. You run a command that says Fury conflict resolve, and you choose one version or the other. Now you might think, well, we've got the same problem again. We've got another eviction and we get the linking errors. But the difference is that we're building from sources this time. And because we're building from sources, the compiler is checking everything at compile time before we even get a chance to run it and before we get a chance for it to fail. So although there are challenges, there are different sorts of challenges between binary compatibility and source compatibility. And source compatibility is generally harder to achieve than binary compatibility, but it's also more fragile in a good way, because it stops us accidentally running something which will fail. So I'm very much of the opinion that source compatibility is far superior to binary compatibility, just because we're forced to run it through a compiler to check that it all works. Now there's a sort of mental exercise here to try and work out how the ecosystem might evolve as a consequence of having these tools available, where everybody can publish builds for all sorts of different projects, everybody can resolve dependency conflicts, diamond dependency conflicts, and everybody can republish them, or they can create pull requests back to the original projects. This is sort of proposing a new ecosystem that is much more fluid than we're familiar with. And I say it's a mental exercise. I'm constantly trying to work out how it might look. But it does give a lot of power to the users to move things forward when they want to. One thing I imagine that will happen, how many people here use type level projects? Does anyone not use any type level projects? Do you say yes for both? Do you use any type level projects like cats or yeah? So I think most people are at least familiar with the type level ecosystem. Type level has projects which work more or less, a lot of them independently of each other, but there are dependencies between them. So I would imagine that things like Shapeless, Spire, Cats would publish workspaces containing that project, and you could import those workspaces in order to use those projects. But I'm sure a lot of people would just like to import the entire type level ecosystem. So it would be completely reasonable for somebody at type level, Miles or Lars or someone, to aggregate, curate compatible versions of all of those projects: Doobie, Cersei, Shapeless, Spire, Cats. So to build a workspace, which is the type level workspace, which imports all of these other workspaces and checks the versions, checks everything compiles, checks the tests pass, and then republishes it. So anybody who then pulls in the type level workspace gets all of these projects available, and they have no diamond dependencies to resolve between these projects. So the work that Maven or SBT does every time it does an eviction, the guesswork it does that it's safe to do that, would actually only be done once, in theory, by someone who checks very carefully whether it's a safe eviction or not, and republished, and then the entire community would benefit from that work. And it might, having got a type level ecosystem or type level workspace published, maybe someone wants to aggregate even more projects into a community build. So a coherent set of versions. Remember, when I say version, I mean git commit hash. A coherent set of these that that we can bring together and curate all of the versions, so that someone can pull in the community build, and they get a massive set of projects that they can depend on, and they can rely on using these without really having to do any work fixing diamond dependencies. Now that's great for the average user, but the person who wants to work at the bleeding edge will probably be experimenting with the head of the master branch of a few of these projects, and they can do that. They can specify, they can change the repository that gets pulled in, and they can make all these changes. So that's potentially a huge change for the ecosystem, but I think one which could potentially liberate it from these very slow releases where we have to wait a very long time for things to come out. I honestly don't know how it will all pan out. I don't know if anyone has any fears or thoughts about that, but I think over the next 2 or 3 years, we're going to need to do a lot of this with Scala 3 coming out, and we're going to need more dynamism, more freedom to quickly publish releases and react to changes in the ecosystem. We can't afford to be waiting months to fix compatibility issues. So I'm sure I've spoken for over an hour already. I have, yeah. I'm going to finish by just showing you how things might work with DOTI, Scala 3, and in the process I'm going to tell you a little bit about schemas. So I've got my ScalaMad project. I'm going to go back to the website project, and I'm going to delete the Shapeless project because I don't need that. So we've got just the website project left there now. Now I told you before that this default is a schema, and a schema is effectively an entire copy of the workspace, or it's one copy. If I have 2 schemas, I've got 2 entire copies of the workspace. But the purpose is for them to be variations of each other. Now, there are different things you might want to do for different reasons to vary a workspace. Remember, the workspace is the entire collection of projects and all of the modules. Let's say you wanted to have a Scala 2.12 and a Scala 2.11 schema. Now, the differences between your sources or your definitions for Scala 2.12 and Scala 2.11 might include some different compiler flags. So that would be a variation between the two. It might include some different sources. You might have some shims that are required for Scala 2.11. it would include a different compiler, of course. That's a difference. So there's a few different things you might want to do, and these are possible by means of schemas. Now, you might think, well, why not just create a different workspace, or even a different Git branch? The reason is that a schema, or the user interface is designed so that the modifications you make are easy to make either globally to all schemas. So if you added a new module to your project, that's probably something you want to do globally. You could just add a module to one schema if you wanted to. If you had say you had a Scala.js schema, maybe you just want to have an extra module for that. But some things you want to do globally, whereas others, like the Scala 2.11 specific parameters, you want to do those only for that particular only for that particular schema. And we can have schemas relating to anything, but typically they will be different versions of Scala, which require different dependencies, different maybe different sources. In the case of some compiler plugins or things that maybe require details of the specifics of the compiler, maybe you do it even for minor versions of the compiler, Scala 2.12.6, Scala 2.12.5, and so on. They may include different platforms, Scala.js, Scala Native. These are all possible, and Scala 3. One other possibility is if you wanted to publish to Maven, you would maybe want to have a schema which replaces your source dependencies with binary dependencies. Now, I don't have the ability to publish to Maven from Fury yet, but I know that it's impossible if we've got source dependencies. But if we can somehow replace those source dependencies and everything still compiles, we replace them with binaries, we've effectively got all of the information we need to publish to Maven Central. So that's a feature I want to add later. But schemas are the means of doing this. So I'm going to add a new schema called Scala 3. So we've now got Scala 3 schema, and you see they've both got one project and 4 repositories and 2 imports. It's a effectively a complete copy. And what I'm going to do is I'm going to update the module front end in the schema. Oops, that's a tab completion bug. In the schema Scala 3 to use a different compiler, and I'm going to update that to use the Dotty compiler. So this change, because I'm specifying the schema, this change will only apply to that one schema. If I went and listed the projects for the default schema, we would see that it's still set to Scala/compiler. In fact, maybe I can even do that like that. So Scala, 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 Dotty, Scala. So in the Scala 3 schema, we're using Dotty. In default, we're using Scala. Okay. So I've made that change. What else do I want to change? Well, maybe I will actually change the definition of the front end to front end 3. And I'm going to modify the source because Scala 3 gives us new syntax. We can write an enum like that. I can get rid of all that, and it's all one line. That's some Dotty code for you if you haven't seen any yet. This compiles to exactly the same thing I just deleted. It's nice lightweight syntax for a sealed trait with some case objects. In fact, I will. That is the syntax, but I'm going to put a deliberate error in there. just so that we can see some output from the Dotty compiler, just to prove it's really using Dotty. Now, I've copied that and I changed the sources, but I need to actually change the sources here. So let's source delete. I've got the wrong module specified, so let's specify the module. In the front end, source delete front end, but only for the schema Scala 3. And we're going to add the source front end 3 only for the schema. We still don't have tab completion on that. There. So there is the change. Now you're maybe wondering, well, we're making all these little tweaks here and there, and it's getting quite hard to track all of the changes that I've made. So there's actually a nice tool I can provide. I can show you, which will give us a diff with another schema. So the current schema is Scala 3. If I diff it with default, we get a list of all of the differences. So the ID of the schema is Scala 3 versus default. The reference to the compiler, website front-end compiler, so there's like a path to the thing we're changing, is Dotty compiler or Scala compiler. So these are different. It's only the differences. The source is 3. That source is missing. So I mean, on the one hand, this is a direct change from front end to front end 3. On the other hand, it's missing from one and missing from the other. And the so I also changed the what the current module is. So in the default schema, the default one, the selected module is tests. In our one, it's front end. So I think with those changes done, I can then run Fury again, and it will do all of this. When it gets to website front end, it will take a little bit longer because it's running a different compiler, and we'll get output that now comes from Dotty. So if we still have this bug here, still haven't worked out why that's happening. Let me just fix that issue by sticking the closing brace on there. That now compiles. Now maybe we want to run this. So what I can do is I can start a REPL. I think that will give me a Dotty REPL. But I need the class path. So what I can do is I can get the class path like that, and I can say Dotty REPL. I think it's -cp. Oh no, it's dash class path. Is it really 2? No, it should be dash. In fact, both of those should have worked. Well, this is Dotty that's at fault rather than me, but I'm going to cheat. Just use Scala -cp because that will work. And then having launched Scala, I can import website._. I've no idea what will happen because I've compiled this with Dotty and I'm trying to run it with Scala. I wonder what happens if I refer to open. Maybe it can't find it at all. No, it can't see Dotty stuff, but it's got the backend. It's got the backend there that we compiled in the earlier phase. So that's if you wanted to run things with a with the REPL, it's just a matter of exporting the class path and running it. That I think I showed you publishing, so I think that covers pretty much everything. Are there any questions about this? Or about in theory, yeah. So Java support for compiling Java is in Bloop, and what Fury does to tell Bloop what to do is it outputs a JSON file with all of the definitions of dependencies and so on that Bloop needs in order to do the building, and then Bloop goes off and does it. I haven't implemented the few lines of code which tell it how to compile or tell it how to output the Java compiler, but it's not very much work, and in theory that's Bloop's problem to go and build that, and it can do that. So yeah, it could be used with Java. There's probably a few other places in the source where I'm sort of searching for directories that contain anything .scala. I would also want to include anything .java. But I could also include I don't know, ETA compiler as well, potentially. I think these are possibilities. I've not really focused at all on Java. The same is true of Scala.js, Scala native. There's not support at the moment, but Bloop supports it, so it's within my reach. I've just focused on other maybe more challenging things. I don't think it's. There's kind of a question of does it make sense? Sorry. Well, the thing is that I anticipate the two existing in parallel. Now, SVT builds usually contain a lot more functionality than just building. They contain publishing details as well, and other things, and that functionality is not going to be provided by Fury, at least not immediately. Now, it might in a year. Maybe people will have written libraries that you can use with Fury. So libraries that they publish that we depend on as applications and run as part of the build, these sorts of things could be provided and used by Fury to do many of the same things that SVT builds do, but right now SVT builds don't. So, sorry, Fury builds don't. I would anticipate that the initial burst of activity relating to Fury will involve nothing more than building projects to the point where other things can depend on them. So just to explain that a little bit, I can build shapeless, and I can build the tests and run the tests, and I can probably do things like code coverage as well using the SVT build. But only the first of those things is necessary for me to depend upon shapeless. I only need to build shapeless itself. I don't even need to build the tests. So building the tests becomes a lower priority. So what I hope, first of all, is that people put the work in, and I will do a lot of it. I'm planning on converting the entire type level ecosystem in the next couple of weeks. If that sounds ambitious, it's not. It's a day's work if everything works. So I'm giving myself a couple of weeks to fix the things that don't work and convert it. That's sort of the amount of work that needs to go in. But by hand, yeah. No, I don't. I don't think so. I think it's much too complicated because there's so much. I mean, it's so hard even for a human to read and understand what that SBT build does. And you saw that it took me less than a minute to clone the shapeless repository and at least point to the files I wanted to compile. Now I probably need to import a couple of dependencies and do some other things. When I converted shapeless before, it took me an hour. That's 1 hour of time learning as I was going. If I were to do it again, it would take me half an hour. And that includes things like code generation. Code generation is always a challenge because I'm having to read the SBT file to understand what it does. There's basically no way I could write a general tool that would read the SBT build files, understand what they do, and then produce Fury builds that do the same thing. I think building from scratch, or writing the builds from scratch, is a much better solution and much better understood. And because there are other learning advantages to that as well. Now, maybe, I hadn't thought of this before, but just maybe, if you have enough Java projects that are built on Maven, maybe Maven builds are consistent enough, and there are such a vast number of Java projects that would be worth a tool to do the conversion. I would speculate that maybe when Fury is established, if Fury is established, that would be a possibility. But the Scala projects, we don't have that many. I mean, there's probably, if I were to convert 50 Scala projects, that would probably be 95% of people's dependencies, I would have thought. And the remaining 5% can be done on demand, and hopefully by the time 50 have been converted, then everything else is a lot easier. So automatic conversion, no. Maybe someone who knows SBT better than I do would have a go at it, but it's probably not in my interests.
If you have multiple modules that depend, for example, on cat, the same version of cat, will have to compile for every module? Or
No. So when it works out the graph of dependencies, it will realize that cats. Well, first of all, it will potentially notice that there are different versions of cats and force you to fix it. But once it forces you to fix on an exact version, it will only build that once. I am exploring the idea of publishing binaries in some way, or sharing binaries that get built, so that we don't have to build everything from source every time. Well, it wouldn't be every time, but the first time. So in a company of like, say, I don't know, 10 or even 1,000 people, the first person who encounters a particular build would build the binaries and then share that within some local network. I'm exploring possibilities around that, which would potentially save time. Well, no, because I would do it in a way that publishes them against a hash which corresponds to the unique specification for that build. Now that might mean there are many more things published, because every little fragile change, causes a completely new binary, and everything downstream of it to be different. Maybe that happens, but it would still save some. It would still save some computation, I would hope. Sorry? So questions or pizza? You can, yeah. Yeah. Um, I hadn't planned. Well, no, not in the short term. I'd planned. I mean, I would like to have Akka, and I'm hesitant to say Play because I think Play has one of the most complicated builds of anything, and plus Play projects have complicated builds because I think it has to run. It has to run something. I would hope to get some help with Play. Akka, I think, is not too complicated. I did speak to Roland Kuhn about it. He told me the build is not horrendous. It doesn't do weird stuff. So mm. Okay, so we can depend on binaries as well. It I can so I didn't want to do that. I wanted to list the binaries. We don't have any binaries, but I can add a binary. Can anyone tell me their favourite binary dependency that you need to tell me the organisation or the group ID, the artifact ID, and the version number? Does anyone know any of them off by heart? So it's is it com dot shapeless 212 version number? Is it 230? So I think I don't know if I've got a good way of detecting whether this actually worked, but anyway, you can say I added the binary, and well, I added it to front end. Let's just I'm intrigued now as to see whether we got this right or whether there was an error that we didn't see. But last thing I do before we have pizza. Oh no, this is never going to work because we're still using Scala 3. Scala 3 is never going to work with shapeless 212. So anyway, in theory, that's how it would work. You would just add binaries, and if you really wanted to carry on with binary dependencies, you can do that. But you do have the possibility of working with sources instead. I don't think the binary. I don't think publishing binary artifacts will go away overnight. People are going to carry on doing this for a long time. Yeah, exactly. So binary between Java libraries is quite a lot easier to manage, or at least well established. So yeah, that's something that would still continue. But I mean, why not use Fury to build the Java projects as well if you want to? If it can compile Java, it can depend on if those repositories are public. It's all possible. Okay. Sorry? Oh, did I build Fury with Fury? Yeah. Let's. So, well, I do build Fury with Fury, but I actually build it with something called Rage, which is another. So I'm using Rage to build Fury now. Rage is just a clone of Fury, but if I break the build, I need another. I need something that's still working. Yeah. So basically, I use Rage to build Fury, and then when that builds, it will. So that is everything that's required to build Fury. I didn't show you this command. You can run Fury build save. That will save a jar file, or a collection of jars for that particular, for the thing you've just been building. And Fury has now restarted, which means I can build a new copy of Rage. Rage is already up to date because it hasn't changed. But I then use Fury to build Rage. So I'm doing these two in lockstep. And if I somehow manage to mess up both of them, then I can just call bloop to build the sources directly. But yes, I'm using Fury to build Fury, and it's quite nice. So I'm dog fooding. Do you want to ask me any other questions over pizza, or go on last one?
Why the specification file is not a format for
Um,
I thinking if you have a lot of dependencies and you want to add like paths,
yeah.
you would need to add in one line like
Yeah, but nobody's checking those if you add them manually. I want them to be checked. So Fury will do various checks. It will guarantee some sort of consistency of the file. And the thing is, you can edit this workspace file. There's nothing to stop me changing the file names here, but it's not designed for that, and Fury will report any errors to you if they happen. But Fury is very much designed for scripting, so I could do for x in I could do something like this: Magnolia Mercator. Fury dependency add -x/core, and that would just add all of those dependencies, as you see there. So it's scriptable if you do want to do that. And if I add the -raw, I can get just a list of those modules in a format that is useful for plugging into a shell script. So I'm very much command line oriented. So I've added the features I would want to be able to use. Someone maybe later will build a GUI or a web interface or something for Fury. Let them. But yeah, everything is designed for the command line. So I said that was the last question. So should we get some pizza? Yep. Thank you.